Something I hadn't tackled quite yet was server-side rendering. And server-side rendering is something that you use to render routes to HTML. And why this is important is because Experience Editor relies on your application, your Sitecore JSS application being fully server-side rendered when the page loads. So this is really done with a different bundle in your application. And this bundle really exports a single function called render view. And my render view, this is sort of a simplified version of this, but you have total control over this function. You can do whatever you want in it. And you get some parameters passed to it. So you get a callback. So this function is asynchronous. And basically, whenever you're done rendering your HTML, you call the callback with the rendered HTML. And that indicates that you're done with your work and the other process can take over. You also get the path, which is the current route that's rendered. And you actually get passed in a data parameter as well. And this is really the layout service data, and you get past this in the server-side rendered mode. You also get a viewBag object, which is, I think the most important thing in there to note is the dictionary comes from there. So the dictionary from your Sitecore JSS application gets loaded from there. And really, you can do any pre-processing or pre-fetching in here that you want to, but ultimately you're responsible for doing some sort of render function. And I was really lucky in Svelte. It has a really great support for server-side rendering, and you can tell it to generate these special functions to do server-side rendering. So basically, I'm passing in different props, all the different props that I get passed from the actual render view function itself. So I'm passing in the state that I get passed from layout service data. And so I'm not making external requests, really, when I'm doing my server-side rendering. I'm trying to rely on using the data I get actually passed myself. So, and ultimately, just calling callback after, after it's finally completed. And one thing I want to talk about a little bit is, I mentioned that Svelte has, you can tell it to build special server-side functions that render server-side, your code server-side. And I was really curious on how it actually stood up performance-wise compared to, say, React. So when you build your React application, when your bundle gets built, it really converts this, your component into a JavaScript representation of your component, essentially. So you can see all these calls to create element in here. And this is probably exactly what you expect your HTML to look like if it was JavaScript. So it has a ton of these create element components. And when you actually do server-side rendering in React, it actually calls all this code. So all this, a good chunk of this, there's quite a bit here. There's a little overhead there. I'm not saying it's slow, but it's overhead. And Svelte solves this problem in a different way. So this is the server-side rendering function for that content block component. And you'll notice this component just returns a string. And it's a template literal, and any nested components are inside that as well. And it's just calling render on those as well. So really, Svelte is just building strings in server-side rendering mode. And I think that's a unique take on it. So because Svelte is a compiler, it can do these optimizations, and it could lead to some interesting results. So I was curious, how much does this matter? Like, how much is building strings slow? Has React have something secret that it does? And I set up a test. So one thing I've been doing quite a bit is you can actually import the render view function from a built server bundle. So this is something I've done I have a couple different use cases for this. But basically, I set up a test, and I would call render view 1,000 times. And I did this across all the official client frameworks, and I did the Svelte as well. So I really wanted to see, how long it took to do those 1,000 renders. So I really wanted to beat React because it had all that code, and it was pretty fast. I was 1,100 milliseconds is for all those 1,000 renders, so that's fast. View slightly slower, but still, all these times are extremely fast. But I guess building strings is faster, so Svelte kind of blew them all out of the water. So just the simple string building seemed to be the way to go there. So I did Angular as well. You notice Angular's not there. I kind of threw my graph off a little bit. There's something wrong there. I'm not saying this, there's a bug. Okay, so you can make a couple changes and get it to look like this. And that's still fast, right? But Svelte is significantly faster than that. So, and the other problem you have to solve in server-side rendering is if you want to use connected GraphQL and say your client framework doesn't support asynchronous requests during server-side rendering. So you saw in that thing, you saw in my function call, I do app.render. I don't await that function. It's not asynchronous. So I really needed a solution for this. So if you're in that situation, connected GraphQL really isn't free. There are solutions, but they all add a little bit of overhead. So Vue has the same issue, and it really solves this problem in this way. So the rendering for Vue is not asynchronous. So basically, the Vue sample app will crawl the layout service data and build an instance of that component that corresponds with the layout service data. And it'll check a place in that component to see if it has a GraphQL query associated with it. And if it does, it'll prefetch that query before the server-side rendering happens. So when server-side rendering actually takes place, it just comes from cache. So it prefetches all those queries and then just renders out. React also has this, but it's a little more hidden. So it uses this render to string with data function from React Apollo, which looks asynchronous, but if you actually look at the code in it, what it does is it actually calls render once on your application, and it collects all the different promises that it finds, and it waits on them. It waits for them to finish. And after all those promises resolve, it calls render a second time, and all that data just comes from cache in that second render, and the application can render with the current data. So these are the two avenues that the official client frameworks took, and I ended up taking the double render method. So I like that it really relied on my components, and I could have access to my entire component state in my GraphQL queries. So that's the method I took. Basically, I have a GraphQL query that I've wrapped. I have normal mode, and I do like a one pass on my application. And then after all those promises resolve, I switch to cache-only mode, and it just renders again from cache. So, but ultimately, like a lot of aspects of your application, a lot of these things are going to be up to you. Either one of those routes is perfectly fine to do either with GraphQL, and you have all the control in the world for all the different choices you're going to make with your implementation. I will say though, when you see your server-side render the first time, it's a pretty good feeling. It's great to see your application fully render server-side. So, just a really conclusion. Svelte is I think it holds a lot of promise, and I hope that some of the stuff I showed today, made you interested in it, and you think that it's a framework worth watching. And then ultimately, Sitecore JSS is a foundation. You can bring your own application framework to it, and really, it's at its core, it's a layout service call that you're rendering out in your own way. So, just some resources if you want to try out the JSS Svelte implementation. I also included some links for the JSS sample applications and the packages that they've built out as well. I couldn't have done my implementation without them open sourcing their code and making that available to everyone. So it was a great resource for me. And if you go through this process as well, you're going to end up digging through those repositories, and yeah, they'll be a great resource.